Hey guys, this is Geethanjali, and in today's video, we'll be learning about the evidences of evolution. Embryological evidence was given by Ernst Haeckel. So, what he basically noticed was that the adult features of few organisms passed on to the embryos of the more recent or more evolved organisms. For example, our human embryo, it has gill slits and also a post-anal tail. But these are vestigial and they do not occur in adult humans, right? But these features are present in fish, even in the adult forms. So he basically meant to say that the features of the adult forms would pass on to the next organism in the evolutionary ladder. But this was obviously false. We are not evolved from fishes but apes. So Karst von Boyer, he carefully observed this evidence and disproved this embryological evidence because he noticed that this does not happen all the time. The adult features do not always pass to the embryo of the other organisms. In fact, when a particular organism is evolved from another organism, it has to share similarity in its adult forms itself, but not in the embryo form, like he gave the example. But this doesn't mean that evolution does not take place. Evolution does take place, but not as Ernst Haeckel explained through his embryological evidence. Coming to the next evidence, which was pretty much solid and accepted, that is the paleontological evidence that comes from the fossils, the skeleton remains, etc., from the dinosaurs, apes, etc. So these evidences help us a lot to understand even the anatomical features of some extinct organisms, and they're extremely useful to understand evolution. And these fossils, they come from sedimentary rocks. As they get compressed over a long period of time over the organisms, and their print falls on these rocks, but the organism itself, it decays and disappears. Coming to divergent evolution. So divergent evolution basically refers to a common ancestor which gives rise to species which are adapted to different environments. Like suppose this is for water, this is for land, and this is for desert, something like that. To understand this, let us take the example of forelimbs of different mammals. So you can see this forelimb of a man, cheetah, whale, bat. And the functions of these forelimbs are different. Here it helps the bat to fly, here to swim, okay, here to run, okay, and here to hold things with a strong grip, etc. So you see, even though they belong to the same class, that is, all of them are mammals, and even the structure are anatomically similar. You can see they have these carpals, metacarpals, etc., but their function is different. So such organs are called homologous organs. That means they are similar in origin but different in function. Another example here is the thorn of bougainvillea and the tendrils of cucurbita. So they both arise from the same type of bud, but their functions are different. So thorn is to protect from grazing animals, and the tendrils is to climb up a support, right? So you can see this is also an example of homologous organs, and this type of evolution is called divergent evolution, where the common ancestor gives rise to species which are adapted to different sort of environments. Coming to the opposite of this, that is the convergent evolution. So convergent is the opposite of divergent, and here we see analogous organs. That means they have the same function but different origin. So here different unrelated species, they end up in the same environment. So that is why they have these analogous organs, and this type of evolution is called the convergent evolution. So here we have the examples of eyes of octopus and mammals. So we know the function here of eyes is to see in general, but we know octopus and mammals are completely different organisms. Here we have an invertebrate and here we have vertebrate, and even the anatomy of their eyes will be different, but the function is the same, to see. Next is the flippers of penguins and dolphins. So here we have aves and here we have mammals. So here are also two different classes, but the function is the same, to swim, because they are in the similar environments, right? They are in the aquatic environment and they need to swim. So even though they're completely different organisms, they have to adapt for a similar function. For a plant example for this is sweet potato, which is a root modification, and potato, which is a stem modification, but the function of these is still the same, to store nutrients. Coming to another solid evidence for evolution, that is natural selection. So one famous example of natural selection is the case of the peppered moth in the Industrial Revolution. So we know that this Industrial Revolution took place in England in the 1920. So before 1920, this peppered moth, which was there, it had two variations. Okay, one was dark winged, it was basically melanized, and one was light winged, or you can say there was no melanin. So before industrial, sorry, this is revolution. So before industrial revolution, the white peppered moth were more in number and were more dominant because they could be camouflaged on the tree because of the lichens present. But after industrial revolution, the bark of the tree, it got covered with soot, dust, and it became darker. And because of that, the white peppered moth could no longer be camouflaged, but the black peppered moth could be camouflaged, and this became dominant. So why here camouflage is coming? Because the predator, okay, like the birds or eagles, whatever, they will be able to detect the dark wing moth here, and they can easily consume it, and it will be difficult to catch these white peppered moths because they are camouflaged with the trees here. But after industrial revolution or industrialization, the scenario was completely changed. So the predators like the birds and eagles could detect the white peppered moths because there was a contrast here between white and black, and they could not detect the black peppered moth because they were camouflaged with the bark of the tree. So you can see this is a classic example of natural selection. So the nature selects the variation or the built-in. Now these population had a built-in variation that was having dark wing or light wing. So this built-in variation helped different individuals according to the environment. Sometimes human involvement is so much that usually they decide which organism thrives directly or indirectly. So then we say that anthropogenic action, that is artificial selection. Example of this is, drug resistant, not drug resistant, antibiotic resistant bacteria, or mosquitoes resistant to repellents, etc. So what happens in this case is that we have two variations in the same population or in the same species, one that are vulnerable to the antibiotic and one that is not. We know that bacteria have plasmids, right, sometimes. So in the same species, some may have the plasmids and some may not have. So when we use antibiotics, it will wipe out all the bacteria that do not have the plasmid and will only keep the bacteria containing the plasmid. And next time when we find this species, we will only be able to find the ones with plasmids, and this bacteria will no longer be sensitive to the antibiotic and it becomes resistant. Same case with the mosquitoes and pesticides and herbicides. Hope you understood the various evidences for evolution.